This is John, and this is lesson 10 for year 13 physics, and this lesson is on LCR circuits and impedance. So an LCR series circuit is one which has the inductor, capacitor and resistor all connected together. So in an LCR circuit, the impedance and the voltages will change as the frequency of the supply changes. Now, how do you get the voltage across the components? So VR is IR, where R is a constant. VC is XIC, where XC is 1 over 2 pi FC. So the XC can change if the F changes, okay, or the frequency changes. And VL, which is the voltage across the inductor, is IXL, and XL is 2 pi FL. So if the frequency is going to increase, XL will increase. Now the resistance of the resistor stays constant because it's unaffected by frequency. However, both reactances XC and XL depend on frequency. So we can use a phasor diagram to show the impedance. So for low frequencies, when the frequency is low, so that means when the F decreases, XC is going to increase. So you've got a longer line going down. Okay, so this is your resistor, this is the reactance of the inductor, and you have the reactance of the capacitor. So XC is greater than XL, and so XT, the resultant reactance, is XC minus XL because that's a bigger one. Okay, so when you do the XC minus XL, okay, so you end up with something like this. So what is your impedance? So you look at that one. So you've got the R squared, and then this is the XC minus XL squared, and you complete your parallelogram, and that's your impedance. And this is for low frequencies. Now when you increase the frequency, because XL is 2 pi FL, when frequency increases, XL is going to get bigger. So now this one is a bigger arrow, bigger vector. So, and because XL and XC are 180 degrees out of phase, your resultant reactance is XL minus XC. So it's going to point this way. Here's your resistance, and you get your impedance. Okay. Now the voltage phasor diagrams match the impedance phasor diagrams. So the supply voltage is a combination of the resistor voltage and the total voltage of the inductor and capacitor. So these are voltage phasors for low frequencies and voltage phasors for high frequency. At low frequency, you have the supply voltage lagging the resistor voltage, okay, because the capacitor voltage is greater. But at high frequencies, the supply voltage will lead the resistor voltage because the inductor voltage is greater, so you have your resultant pointing this way. The circuit current will always be in phase with the resistor voltage. And I've done some questions on this, LCR circuits and impedance. So you can take a look, try solving them, and then look at my answers if you'd like to check. So here's one, and then there are a couple more over here if you'd like to take a look. So there you go.